Okay, so we are FTC Team 135 Robo Force. We're a fifth-year team from the Bay Area. And this is our robot for the 2023 to 2024 center stage season for the first challenge. And so this is our robot. We named it Brad. And so essentially we've created it from many components. So first of all, let's start from like the overall game this season, which is basically there's like a bunch of pixels on the ground. You pick those pixels up, you have to put them on a board called a backdrop, and at the end of the game, basically whoever creates like the best pattern, or like whoever puts the most pixels gets awarded like different points. Whoever has the most points wins. And so how we do this is that we have a intake system which is for the pixels, and here is surgical tubing, and that spins around, which is connected by a motor here, which isn't, you can't see it here, but like, anyways, you have linkage here that can make the intake go up and down to adjust for, because these pixels on some sides of the game, they're like stacked, so we need 3 different levels to adjust for each stack level, and also there's and after that we have this, we have our claw. And what this is we have a microserver here and we have 2 claws. So let me get a pixel. What this does is that the way that we approach our pixel design is that because we have a hole in the middle, we do this, and then when we expand, we can hold the pixels, and when we close it, we can drop it pretty reliably. And also because in this game, we're only allowed to possess 2 pixels at a time. So if you look at here, we have this apparatus here, which is what we call a door. And so what this does is that when we go in here, it makes sure that it can't come out. But once we grab with our claw, we take it out, it can come out like this. And we also have a funnel system here to make sure that only one goes in at a time. And the way our magazine is designed is that you can only fit 2 pixels in here. Like if you try to fit any more, let's say there's already here. If you try to fit any more, you can't do that. And also we made it so that you can do a top view. And there's this little door here, a little white flap. I don't know if you can see it from here, but here. And what this does is that when you're going in, right, you can press this down, but from the other way, if we do this, you can't push it back down. So that enables us to make sure that the pixels are in the same orientation every time. And after that, we have this arm here, which is powered by these servos. And this swings over like this. And once we're here, we can also adjust the wrist from this servo right here. Because this is for the arm. And then this can go up and down. And this can also twist left or right depending on which orientation we want it in. And the way that we make it go up and down is from these linear slides, which are powered by these 2 motors right here. This one and this one. And so these are just linear slides that you can find on like your cabinets and stuff right here. That just make it go up. This is our max height because our backdrop is about this tall, so we don't need any more height than this. And now that we're done talking about all the components, we can talk about something like our drone launcher, because in our game we have like a paper airplane that we have to shoot into a certain zone to get points. And so this is how we did it. And this has gone through a lot of iterations. And also we have this is called blue spring steel. And what this is, it's a form of steel. It's an alloy that is really flexible, so then it acts almost like a spring. So this enables our hang to be very consistent, and it's probably the most consistent part of a robot. And you might have noticed something about the way our robot moves. So like if you have like a car, for example, you'd have to like turn like this. But with our robot, you can just go like this sideways.
It's a mechanism wheel.
Yeah, it's a mechanism. So if we flip over, you can see that our wheels are consisted of rollers that are slanted at 45 degrees. This enables holonomic driving, and so we can move forward or backwards, and we can also move side to side without turning. And also how we localize our thing, basically this means like how do we know where we are on the field at any point in time? Because in our games, there's a 30-second period at the start of the game where it's autonomous. You can't control it with the driver, so it's only relying on code. And to do that, you have to know where your robot is on the field to do different aspects of the game to earn points. And so how we do that is that we have these dead wheels, which don't actually affect anything, but they roll along with our robot's movement. So depending on how much this rolls, and this rolls, and this rolls, we can see how much they've rolled, and thus triangulate the robot's position from there.
What program did you use to code this?
Java. What's this? We use Android Studio. Java.